Welcome to your first thermochemistry video and your first video of AP Chemistry. We are going to start off by talking about some basic introductory information for thermochemistry that you're going to need to know. And the first of that is point of view. Whenever we're discussing anything in chemistry, we're always talking from the point of view of the system. The system is whatever we're studying. The surroundings is everything else of the entire universe. So for example, let's say we were studying this copper nitrate in this flask here. So the blue copper nitrate itself is the system. The glass flask and the air around it and the school around that and everything all the way out to the edge of the universe, that's the surroundings. So every time that we discuss something going in or out, that's in and out relative to the point of view of the system. And that point of view can change depending on whether you're thinking about yourself as the researcher or what's happening in the flask. For example, if I feel that it is cool, my point of view, then I would be the system. Or if I'm feeling that it's cool and so I'm trying to think of what's going on in the flask, then the copper nitrate is the system. I'm looking at its point of view. So you have to be really careful about your point of view and what it means as far as what's going on inside the reaction. We're always talking about the reaction, not so much ourselves. So with that in mind, let's talk about the first law of thermodynamics, which says that energy is neither created nor destroyed. Energy is conserved. Energy moves around between the system and the surroundings, but all the energy in the universe, the amount of energy the universe has, stays the same. Therefore, there's two types of reaction. Endothermic reaction means that the system has gained energy from the surroundings. So if this was a reaction and it was endothermic reaction, it would be absorbing energy from the air, from me if I'm touching it, from the table, from wherever it can, and therefore because it's absorbing energy, it's called endothermic. And that is given a sign of positive. Positive and negative in chemistry do not necessarily mean the same things as positive and negative in math. In math, a negative number is something less than 0. In science, a positive number versus a negative number usually indicates your direction. So in this case, the direction is in, if it's positive. Energy is going into the system. The other type of reaction is called exothermic. And in that case, the system is releasing energy out to the surroundings. So if this is our system and energy is going out, then it would have a negative sign because the energy is leaving. So positive in, negative out. Now what does that mean from my point of view? Well, if I was holding this flask and it's an exothermic reaction going on inside, I would feel heat because that energy is coming out. It would be coming out in heat, and I, being the surroundings, would feel that heat. So if something feels hot, it's an exothermic reaction. Conversely, if something feels cold, it's an endothermic reaction because it's absorbing your heat, it's absorbing your energy. So if I put my hand on it, it's sucking the heat out of me, and therefore I feel cold because it's absorbing my heat. The third thing we want to talk about is work and heat. So the delta E, delta stands for change. The change in energy, because energy can change between the system and the surroundings, is equal to the heat, which is represented by a lowercase q. You be very careful about capital versus lowercase letters in chemistry. It's added to the work, which is lowercase w. Now heat, as we'd already talked about, can go into the system or out of the system. If the heat goes into the system, then that's a positive Q. If the heat goes out of the system, that's a negative Q. The same thing happens with the work. If the system has work done on it, let's say, for example, I had a marshmallow and I was squishing it, okay? I am doing work on the system, the marshmallow being the system. Then it would be positive W. I am doing the work. Also, you can have systems where work is going out. For example, let's say that you have an engine driving a motor. So the engine is pushing something. And so therefore, it is doing work on the surroundings. So again, it's all about the point of view of the system. Positive means in, whether it's heat or work. Negative, it means out. Again, heat or work. And then if you have positive Q's and negative W's and so on and so forth, you can have either a positive or a negative E. So that will tell you if it's endothermic or exothermic. Remember, positive E means endothermic. Negative E means exothermic. So if you have a negative Q and a negative W, then you'd have a negative E. If you had a positive Q and a positive W, you'd have a positive E, so endothermic. If you have a negative Q and a positive W, well, then it depends whether it's going to be exothermic or endothermic by the values, which one's bigger, and that will determine whether the delta E is positive or negative, and therefore is an endothermic or exothermic reaction. So that's your first lesson, first introduction to thermochemistry. You're going to have to keep these in mind as you go through this unit, and you are going to have to remember your signs. Positive in, negative out. Thank you.